Hello and welcome back to Coach Quant. Today we're going to be looking at a problem on dice. A gambling establishment gives us a game with a six-sided die where we receive payment equal to the number that we've rolled. If we're unsatisfied with our first roll, we can choose to roll again. What is the fair value of this game? So obviously you want to maximize um, the roll that we get with the die, right? So we can either get uh, 1, 2, 3, 4, 5, or 6. And so we want to find out, given that we have the ability to re-roll the dice, what is the fair value of this game? So um, the first question is, on what case would we choose to re-roll versus not? And so the answer to this question is to first find out what is the expected value on any given roll. And so that can be calculated fairly easily just by summing up the total number of possibilities and divide by 6, right? This is the expected value of any roll, and this is equal to 3.5. So the expected value of any one roll is 3.5. And so if we roll um, anything more than a 3.5, right? So if we roll on our first case, if we roll a 4, 5, or 6, so first roll, if we get 4, 5, or 6, then we don't re-roll. But if we get less than that, then we do re-roll, because that's telling us that we've gotten a number which is less than the expected um, value of the dice. And so if we roll again, we actually have a higher probability of getting a larger number than a lower number. So it's in our favor if we get a 1, 2, or 3 on our first roll to re-roll. And so on our second roll, right, it's expected that we get a 3.5. So if we compute the fair value of this game, it's a combination of two things. It's a combination of getting a 4, 5, or 6 on the first roll, right? So we either get this or we do a second roll if that doesn't happen and we get 3.5. So the total expected value for the game, the total fair value, is just equal to the probability of getting 4, 5, or 6 on the first roll times the expected value of getting a 4, 5, or 6, right? And the expected value is just the average of those three numbers, which is 5, plus the probability of getting a 1, 2, or 3 on the first roll times the expected value of the second roll, which is 3.5. And we know the probability of getting a 4, 5, or 6 is just 1/2. And again, probably 1, 2, and 3 is just 1/2. So this is just equal to 1/2 times 5 plus 1/2 times 3.5, which is equal to 4.25. So the expected value of the game is 4.25, and we are done. To see many more problems like these, I really recommend you go check out our website, coachquant.com. You have many, many, many more problems just like these with solutions and hints from many different quant firms. You can go select the firm you are interviewing at, and we have past interview questions from those firms. I really recommend you use coachquant.com to study for your quant interviews. It's completely free. Thank you very much.